Before sight, before sound, before any other sense could process what was happening, the nose already knew. In the ancient world, smell was not a luxury. It was a survival system, one of the oldest, fastest, and most reliable warning mechanisms the human body possesses. And certain smells, specific combinations of molecules in the air, meant one thing and one thing only. Something dangerous had been here, or something dangerous was about to arrive. The human nose is an instrument built by millions of years of survival pressure. It can detect certain compounds at concentrations measured in parts per trillion. It can distinguish thousands of different odors, and it processes smell differently from any other sense. While sight and sound travel through the thalamus, through the rational thinking brain, smell goes directly to the amygdala, the part of the brain that processes fear and memory, the part that decides, before conscious thought has even begun, whether to freeze or run. This is why certain smells produce instant, involuntary reactions. Before you have decided how to feel about what you are smelling, your body has already responded. In the ancient world, this speed was not incidental. It was the difference between reacting in time and not reacting at all. So what were the smells that ancient humans learned to fear above all others? The first was the smell of large predator. Lions, leopards, hyenas, and the other large carnivores that shared the prehistoric landscape with early humans all carry a specific chemical signature. Filtered urine contains compounds called felinine and other sulfur-based molecules that produce a distinctive, sharp, ammonia-heavy odor. Research has confirmed that many prey species, including humans, show an automatic stress response to these compounds. Not a learned response, an inherited one. The fear of the big cat smell appears to be partially hardwired. Ancient humans who detected predator scent and immediately increased their alertness and changed their behavior were more likely to survive than those who did not. Over generations, this created a population where the smell of large predator triggered a specific physiological cascade. Elevated heart rate, sharpened attention, suppression of hunger and fatigue, the body preparing to act. This response is still present in modern humans. Studies exposing people to felinine compounds without telling them what they were smelling found measurable increases in cortisol and subjective anxiety. The ancient warning system is still running. The second critical smell was the smell of rot and decomposition. The human nose is extraordinarily sensitive to the compounds produced by decomposing organic matter: putrescin, cadaverine, hydrogen sulfide. These molecules appear in the earliest stages of decomposition, before visible decay is apparent, and they trigger an immediate and powerful disgust response. Disgust is not just an emotion. It is one of the oldest immune responses in the human behavioral repertoire. The smell of decomposition signals the presence of dangerous pathogens, bacteria that can cause illness, the same bacteria that, in the ancient world without medicine, could kill within days. The humans who felt the strongest revulsion from the smell of rot, who avoided it most consistently, were the humans who avoided the pathogens it contained, and they were more likely to survive and pass on that sensitivity. Ancient humans encountering the smell of decomposition in the landscape would have changed their behavior immediately, moved away from the source, avoided the water near it, warned others in the group. The smell of death was not just unpleasant, it was a navigational signal. Move, and move now. The third smell was blood. Fresh blood in significant quantities carries a smell that predators can detect from extraordinary distances, and ancient humans knew this. Not through any scientific understanding of scent dispersal, but through direct observation of what happened after blood was spilled in the open. What came afterward, and how quickly it came. The smell of blood was ambiguous in a way that rot and predator were not. Blood could mean the group had made a successful kill. It could mean an injured group member. It could mean a fight had occurred nearby. But it also meant that whatever predators operated in the area were now receiving a powerful signal of exactly where the group was. Ancient humans who moved quickly after a kill, who processed and removed the evidence, who did not linger in blood-heavy environments, were less likely to attract the secondary attention that blood scent inevitably produced. The smell of blood in quantity was not celebrated. It was treated as a timer. Act quickly or accept the consequences of what the smell was now broadcasting to the entire surrounding landscape. Fourth smell was smoke from the wrong direction. Fire was one of the most powerful tools ancient humans possessed, and ancient humans became extraordinarily sensitive to its smell, not just because fire itself was useful, but because fire in the landscape had meaning beyond warmth and cooking. Smoke from an unexpected direction, an unexpected quantity, was one of the primary signals of rival human groups. Other humans moving through the territory, possibly approaching, possibly with intentions that required immediate assessment. The smell of unfamiliar smoke was the smell of the unknown, and in the prehistoric world, the unknown, particularly when it arrived as other humans, demanded immediate attention. Research on surviving traditional communities has documented that smoke reading was a genuine skill. Different types of vegetation produced different smoke signatures. Different fire management techniques produced different patterns. An experienced person could detect from the character of smoke what kind of group had produced it and roughly how large it was. This was not supernatural. It was a highly developed sensory skill built on years of careful observation. And it could be the difference between walking into an ambush and not walking into an ambush. The fifth smell was the body smell of fear. Humans, like many mammals, produce specific chemical signals when under extreme stress. Elevated cortisol changes the composition of sweat. Adrenaline affects the body's chemical output, and these changes are detectable by other humans, even if not consciously recognized. Research has documented that humans can detect stress-associated chemical signals from other humans at concentrations below conscious awareness. The effect on the receiver is real, even when the receiver does not know what they are smelling. Group members who were frightened or in distress were broadcasting that information through their body chemistry, and the group responded with increased alertness, elevated vigilance, a shifting of the collective nervous system toward preparation. This is one of the reasons why fear in a group can spread so quickly without anyone saying a word. The chemical signal moves through the group before the verbal one does. And in the ancient world, this rapid transmission of threat information could mean the difference between a group that was ready and a group that was not. The sixth smell was the specific combination that ancient humans came to associate with serious illness in a group member. Infected wounds, systemic infections, and advanced illness all produce specific chemical signatures. The smell of ketosis in starvation, the sweet decay smell of certain bacterial infections, the specific odor of fever. Ancient humans, living in close proximity with the same small group for their entire lives, became familiar with the healthy smell of each member, and familiar enough to notice when that smell changed. The sixth smell was not just unpleasant. It was information. This person needs help, or this person may be contagious, or this person may not recover. The smell of serious illness in a group member triggered a response that researchers studying traditional communities have documented consistently. Separation, even in communities with strong bonds of care. The sick person cared for, but at a distance. The instinctive avoidance of the specific chemical signals of infection, even among people who genuinely wanted to help. This was not cruelty. It was the behavioral immune system operating at the chemical level. What all of these smells share is the same underlying mechanism. The human nose evolved to detect specific molecular signatures that, in the ancient world, reliably predicted danger, and the brain evolved to respond to those signatures with urgency before conscious thought had time to deliberate. In the ancient world, the few seconds saved by the system were sometimes the only seconds that mattered. The smell arrived first, the body responded, and then, and only then, the conscious mind caught up and began to decide what to do next. This is the real history of the human nose, not an organ of pleasure or flavor. A survival instrument built to read the landscape for threat, calibrated over millions of years to detect the specific chemicals ancient environments produced when something dangerous was near. Drop a comment and tell me which of these surprised you the most. And make sure you are subscribed, because next time we are going somewhere even stranger than this.